So now, what you're looking at here, we're going to make this quick, is the voltage across the current setting resistor for this circuit. It is the op amp right there, wired as a non-inverting comparator. We got a high enough signal to get a high output. Red LED is lit up, even though it's kind of covered right there. These are our multimeter measurement spots right there. We're measuring across this 1,500 ohm resistor. So I decided 1,500 ohms is about the minimum I'm going to use for a circuit that gets close to 15 volts, 14.6 to be more exact. So now we have the output of the op amp. It's high. It does not get to the full positive supply voltage ever. And when it has to provide current, it usually falls about a couple volts less. The LED drops about a couple volts. So yeah, we expect, about this much voltage across the resistor. And then you can divide by its resistance to calculate how much current is flowing. So now, the voltage we're looking at right there is the voltage limiting current through the red LED right there. We have an op amp wired as a non-inverting comparator, but that's not what matters the most. We have about 14.6 volts at the power supply. So it's a relatively high amount of voltage for a circuit like this. And so the output's going to drop about 2 volts. LED is going to drop about 2 volts. We'll have about the rest of the voltage across the resistor. So we don't want to use lower than about 1,500 ohms of resistance, I don't think, because a lower value resistor is going to get hotter than this one. And I think we're close enough to this limit. So what we can do if we want twice the current, just take another resistor right there. So LED got a bit brighter right there, and not all of this current is the LED current, but there you can see it went up significantly. I think it was 9 before. So that's the simple solution if you need more current without making components hotter.